Friends, what if I told you that on Mars, in a silent valley, beneath a crimson sky, a single meteor strike once changed everything? It happened near the edge of Mount Apollinaris when a rocky meteor slammed into the Martian surface, carving hundreds of fresh streaks, scars, and trails across the dusty land. But this wasn't just a random impact. It was a sign that Mars is alive, dynamic, restless, and constantly changing. Welcome to All About Mars Surface, your trusted channel for the latest discoveries from Mars, the solar system, and beyond. Today, we'll explore the mysterious marks left behind by that meteor, uncover the science behind Martian slope streaks, and reveal what these strange patterns tell us about the red planet's ongoing evolution. The European Space Agency's ExoMars orbiter, equipped with the color and stereo surface imaging system, captured something truly astonishing. From its orbit around Mars, it photographed a region near Mount Apollinaris, showing not only new streaks on the slopes, but also a faint cluster of small impact craters at the base. At first glance, it looked like a scar. But upon closer inspection, scientists realized it was something far more dynamic. It was as if Mars itself had just turned a new page in its geological story, right before our eyes. According to planetary scientists, these dark slope streaks form when thin layers of fine dust suddenly slide down steep terrain. What's even more intriguing, there's no sign of liquid water involved in this process. That means these streaks aren't wet landslides, but dry avalanches, driven entirely by wind, dust, and gravity. On Mars, where the atmosphere is thin and temperatures plunge far below freezing, wind becomes the most powerful sculptor. It lifts dust, rearranges dunes, and paints the surface in shifting shades of red and brown, revealing the planet's restless and ever-changing nature. A recent study published in Nature Communications revealed a stunning fact. Less than 1 in 1,000 of these streaks is caused by an actual meteor impact. That means what happened at Mount Apollinaris is an exceptionally rare event in Martian history. In most cases, the streaks appear due to seasonal temperature shifts and strong winds that loosen dust layers, sending them cascading down slopes. But when a meteor strikes, it adds an entirely new level of energy, carving patterns unlike anything else on the planet. It's a living, breathing planet in its own way, one that moves, shifts, and reshapes itself through time. Its mountains, dunes, and valleys echo with the whispers of dust storms and the scars of meteor strikes. Every new mark on its surface tells a story of motion, erosion, and evolution. Far from being static, Mars is constantly transforming, painting new landscapes with every passing season. Some scientists suggest that Mars quakes and local meteorite collisions may also play a role in forming these slope streaks. However, their impact is localized, not globally significant. The real forces shaping Mars on a planetary scale are wind, dust, and seasonal change. And let's not forget, Mars occasionally experiences planet-wide dust storms that can last for weeks, covering the entire planet and blocking out sunlight. These storms reshape dunes, fill craters, and sometimes even erase old streaks while creating new ones. Orbiters like ExoMars, Mars Reconnaissance Orbiter, and others continue to circle the red planet, capturing breathtaking images and valuable data every single day. They don't just take pictures. They help map the chemical makeup, atmospheric gases, and mineral composition across Mars. Through these detailed surveys, scientists hope to answer profound questions. Did Mars once have flowing water? Could it have supported microbial life? And if so, where did that life go? Each mission brings us one step closer to solving the puzzle of Mars's ancient and mysterious past. The European Space Agency's ExoMars mission has one ultimate goal: to understand the history of water on Mars and uncover whether the planet ever had the right conditions for life. Its orbiters and landers work together to gather evidence, from subsurface minerals to atmospheric chemistry, helping scientists build a complete picture of Mars' evolution. The data ExoMars sends back is also vital for future human exploration. By studying Martian dust, radiation levels, and surface stability, we are preparing for the day when humans might finally set foot on the red planet. And so, this single impact near Mount Apollinaris isn't just a scar, it's a reminder. A reminder that Mars is far from silent. Beneath its calm red surface lies a world that's still moving, still changing, and still whispering the secrets of its past. Is Mars truly dead? Or is it quietly alive in ways we're only beginning to understand? Stay tuned. Because this is only the beginning, Mars still holds count. Scientists believe that these streaks on Mars form when layers of fine dust suddenly slide down steep slopes. With no evidence of water, they've concluded that these features are caused mainly by dry processes driven by wind and dust activity. The new study in Nature Communications suggests this is a rare phenomenon, as fewer than 1 in 1,000 streaks are caused by rocks impacting Mars. In most cases, seasonal changes lift dust and wind, triggering these streaks. The dynamics of dust, wind, and sand appear to be the main seasonal forces shaping these features. Meteorite impacts and Marsquakes seem to be distinct local factors, but relatively insignificant on a global scale. These observations could lead to a better understanding of what's happening on Mars today. Obtaining long-term, continuous, and global-scale observations that reveal a dynamic Mars is one of the key goals of current and future orbiters. The spacecraft continue to capture stunning images from orbit to help us understand Mars's ancient past and potential habitability. They send back spectacular visuals and provide the best inventory of atmospheric gases and detailed mapping of water-rich regions on the planet's surface. Understanding the history of water on Mars and whether it ever allowed life to flourish remains the main objective of the European Space Agency's ExoMars mission. The featured image covers an area of approximately 6 square kilometers and was captured on December 24, 2024. And so, this single impact near Mount Apollinaris isn't just a scar, it's a reminder. A reminder that Mars is far from silent. That beneath its calm red surface lies a world still moving, still changing, and still whispering the secrets of its past. Is Mars truly dead? Or is it quietly alive in ways we're only beginning to understand? Stay tuned, because this is only the beginning. Mars still holds countless secrets waiting to be uncovered. This is all about Mars' surface, where rocks speak louder than words, shapes tell stories, and shadows hold secrets of the red planet. If this exploration sparked your curiosity, like this video, share it with friends, and subscribe to All About Mars Surface. Next time, we will continue uncovering the silent artistry of Mars, exploring its terrain stone by stone, whisper by whisper. Thank you for watching.